In this video, we will be demonstrating gas-liquid absorption using the Molecule Works MEMX cell. For maximum chemical compatibility, in this application we are using the stainless steel feed plate. Depending on chemical compatibility, a completely polycarbonate cell may be used. On the sweep side of the cell, we are using a polycarbonate cell plate. The cell is loaded with a ceramic PTFE modified Molecule Works membrane. On the feed side, we have a hydrophilic ceramic coating. On the sweep side, we have coated the Molecule Works membrane with a hydrophobic PTFE coating. Our Molecule Works membrane with selective wettability prevents liquid crossover in the cell and keeps the two fluid streams isolated from each other. The membrane is loaded with the hydrophilic side facing the feed side. In this demonstration, we have a stream of H2N2 gas contaminated with ammonia flowing through the sweep side of the cell. The ammonia from the gas stream will be absorbed by a liquid absorbent flowing through the feed side of the cell in a countercurrent fashion to the gas. In this demonstration, we'll be using dilute sulfuric acid with the initial pH of 2.5 at a flow rate of about 50 cc per minute. The sulfuric acid will enter at the lower port of the feed side and exit through the upper port of the feed side, while the gas enters through the top part of the sweep side and flows out of the bottom port. The gas composition on the sweep side before and after the gas absorption process is monitored using a Stanford Research Systems QMS 200 gas analyzer. The sweep side outlet is connected to a second MEMX cell functioning as a dehumidifier in order to protect the mass spec from exposure to excessive moisture in the exiting gas stream. Molecule Works' proprietary sodium A zeolite membrane is being used to selectively remove the moisture from this stream. The setup of this cell will be discussed in further detail at the conclusion of the video. We now have sulfuric acid circulating through the feed side of the cell. We will now introduce the ammonia-enriched gas stream into the sweep side of the Molecule Works MEMX cell at 400 SCCM. As the ammonia from the gas stream is absorbed in the sulfuric acid solution, an almost immediate change in pH is seen, signifying a rapid mass transfer within the MEMX cell. The ammonia signal coming out of the cell is similar to the background detection level of the mass spec. We have now bypassed the cell to observe the ammonia signal of the feed gas. Comparing the feed gas ammonia level to the ammonia signal of the scrubbed gas coming out of the cell, you can see that almost all of the ammonia has been absorbed by the liquid absorbent circulating within the MEMX cell. Now let's talk about the membrane dehumidifier being used to remove moisture from the gas stream before entering the mass spec. The membrane dehumidifier can be used in any orientation. A detailed video of the MEMX cell functioning as a dehumidifier is available on the website. For this application, the sodium A side of the membrane is facing the feed side of the cell. On the sweep side of the cell, we have in-house air flowing to dehumidify the gas stream. The in-house air can be vented to environment. The gas coming out of the MEMX cell being used for gas absorption typically has a high humidity. It is flowing at 400 SCCM as it enters the feed side of the dehumidifying cell. At the moment, we are measuring the humidity of the feed side outlet without any sweep air flowing. We will now begin flowing dry house air at 4 liters per minute on the sweep side of the MEMX cell. An immediate drop in humidity of the previously moist gas stream is seen. This dry gas is now ready to be safely sampled by the mass spec or similar instruments.